difference of two squares. When is a difference of two squares? When is it dots? Some people call it dots. What needs to be in place? Well, let's just make a little note over here. Three things need to be in place. You need two terms. Why does it do that? You need two terms. They need to be separated by a minus. It won't work if there's a plus in between. And then the third thing is that they both must be perfect squares. So you must be able to get the square root of both of those terms. Okay, now let's evaluate. If we look at the first one. Let's go through that criteria. Two terms? Yes. Separated by minus? Yes. We can get the square root of x squared, which will just be x, and we'll talk about that some more later. And then we can get the square root of 4, which is equal to 2. So we can use the difference of two squares. How do we factorize 4 dots? Difference of two squares. It will break up into two sets of brackets. There they are. The square root of the first one, there it is. The square root of the second one, there it is. And 1 plus and 1 minus. Fully factorized by using dots. If you multiply that out by using FOIL, you'll see that you get back to your original x squared minus 4. Okay, I hope that went well. Now remember, we need to know our basics. Grade 9s, that would be considered a basic. Because we can always obviously zhuzh it up a little bit, and then you mustn't lose your marbles. And if we don't know our basics, then we won't be able to cope when they just start challenging us a little bit more. Let's look at this one. Are there two terms? Yes. Are they separated by a minus? Yes. Are they both perfect squares? Yes. 25 is a perfect square. P squared is a perfect square, 64 is a perfect square, and Q squared is also a perfect square. So for dots, it always breaks up into two sets of brackets. Square root of 25, 5. Square root of P squared is P. That goes into both sets of brackets. Square root of 64 is 8. Square root of Q squared is Q. There we go, into both sets of brackets, exactly the same. What do we need to remember? 1 plus, 1 minus. Doesn't matter which one comes first. Okay, fully factorized. Let's look at the next one. Are there two terms? Yes. Are they separated by a minus? Yes. Are they both perfect squares? Yes. If we look at 16x to the power of 8 and we look at 1, well, the square root of 1 is just 1. I'm always surprised at how many people get bowled out by that. And the square root of 16x to the power of 8 is equal to 4x to the power of 4. Because x to the power of 4 times x to the power of 4, so that number times itself gives you x to the power of 8. So this relies on some exponent knowledge. All right, what is the shortcut? Do you know the shortcut? Let's say you've got x to the power of 10. That will be x to the power of 5 because the square root means that there's an imaginary 2. So it will be 10 divided by 2. So you tell me, if it's x to the power of 16, what will the square root be? X to the power of 8, not x to the power of 4. Even though 16 is a perfect square, it is in the exponent. It is not a base. Be very mindful of this. This idea is very important. Okay, two terms separated by a minus, both perfect squares. Two sets of brackets. The square root of 1 is just that. The square root of that is 4x to the power of 4. Oh, that's so ugly. Plus and minus. And there you go. Now we need to start checking. We need to be very careful, grade 9s. Is this fully factorized? We need to go evaluate. If we look at this bracket over here, can you see that that is dots again? Why do I say that? Because 4x to the power of 4 is a perfect square. 1 is a perfect square, and they are separated by a minus. The first bracket will stay what it is because there's a plus in between, so that's done. But this bracket is dots again, so that one will break up into two sets of brackets, 2x squared, 2x squared, 1, 1, 1 plus, and 1 minus. Is it fully factorized now? Well, we know that one is fully factorized. That one is fully factorized. Is this one fully factorized? Well, yes, because the 2 is in a perfect square. So we are done, finally. So Make sure that it is fully factorized. Let's look at number 4. Now, I find that students normally find this quite tricky. Let's see if we can use dots to factorize this. 2 terms? Yes, there's 2 different terms. They are separated by a minus. Yes, they are. And are they both perfect squares? Well, 16 is a perfect square. And this, no man. And this is also a perfect square. Anything that's to the power of 2 just actually says, yes, I'm a perfect square. It is a perfect square and it will be x plus y. So if we factorize that, 2 sets of brackets, 4 and 4, the square root of x plus y is just x plus y. X plus y. And what needs to go in between? 1 plus and 1 minus. So now let's just make it look a little bit better. Goodness. This would be x plus y. I can remove those brackets, plus 4. And this will be x plus y minus 4. And there it's fully factorized. We use dots, and the trick with this is just to spot that it is in fact 2 perfect squares. That gives it away that it's a perfect square, and you need to know that 16 is a perfect square. All right, let's see what's next.